Welcome class to this video on using Algebra Tiles. This video is meant to help you complete the handout that you were given today in class. I'll try to make it as brief as possible and as painless as possible. Have fun. Okay, so your handout has this section here that you can see on the screen, and it's just introducing what algebra tiles are. And so for our purposes, we're going to be treating dark tiles, you can see on the right hand side here, as positive, and white tiles as negative. Now the little squares, which you can see on your screen here and here, the little squares, they represent 1. So for negative, that is obviously -1, and for positive, that is just +1. Then this longer thin rectangle represents the letter X for positive, and then for negative it's -X. And then finally this larger square, this represents for positive x squared, and this one is -x squared. And it might seem a little arbitrary as to how they've come up with this, but it does make a little sense. So if you think of this square as having a side of 1, then the area of that little square is going to be 1 times 1, which is 1. And if you notice, then this little square has the same width as the rectangle here, and so you could think of that as having a width of 1. And then we don't know the length of the rectangle, so we would say that is x. We don't know it, and 1 times x gives us an area of x. And then looking at the larger square has a length and width which are equivalent to the unknown length of this rectangle. So this rectangle here, see this length, is the same as this length and the same as this length. So you can then think this is x and this is x. Well, what's x times x? X times x is going to be x squared. So that's how we got x squared here. And we know that x times x is x squared because x is any number times x means any number times itself. 3 times 3 is 3 squared. 4 times 4 is 4 squared. X times x is x squared. And then, as I said, over here on the left-hand side, we have the negatives that we're representing with the white tiles. Alright, note, you see this here? We have a black +1 and a -1 represents what value? Well, think about it. What is 1? 1 plus -1. Well, that's the same thing as writing 1 minus 1. Both of them are going to equal 0. So if you have a pair like that, a black and a white one, the black one representing positive, the white one representing negative, then it's going to represent the value 0. And this representation is known as a zero pair. So your handout has these 3 examples that you can work through. I'm going to go through a couple of other examples, and then hopefully after you see the examples I've done on the screen, you can fill out the handout, those 3 examples for yourself. You should notice there is a small difference between your handout and C over here. There was a little problem with the handout, and so some of the boxes were kind of combined in your handout. You should see them there. There should be 8 separate single unit boxes. So I'm going to start with this simple example. In this simple example, we can see that we have here 4, right? This is worth 1, 1, 1, 4. So that would be 4. We'll write it in. 4. We'll talk about the order of these things afterwards. So we have 4 there. And then, well, we have here x, and it's a positive x, so we're going to write in plus x, and then we have here positive x squared in the big box, so we write plus x squared. Now I'm going to rewrite this in standard form. X squared plus x plus 4. In standard form means having the highest exponents first and going descending downwards till we end with constants. And you should have gotten that from the polynomials definitions handout. So this here, these set of algebra tiles can be written as x squared plus x plus 4. So another example, in this case, I have a positive 1, I have a negative x, and I have a negative x squared. This time I'm going to start by writing it in standard form, that is with the highest exponent first. And so if I were to write this, I would get negative x squared minus x plus 1. Okay, and I'll show that again. This is the negative x squared, negative x, positive 1. Negative x squared matches to this, negative x matches to this, and positive 1 matches to that. Alright, so now we'll do a little more complicated example. In this example, we can see here that we have 5 unit tiles, and they are negative, 5 negative unit tiles. So we can write that in as negative 5. Negative 5. We have here, let's count them, 1, 2, 3, 4, 5, 6, 7 x tiles. They are positive, so I can write in plus 7x. And then on the right hand side here, I have 4 negative x square tiles. So I could write that in as negative 4x squared. So I'll write it in negative 4x squared. Now writing this in standard form, starting with the highest exponent, I would get negative 4x squared plus 7x minus 5. And that expression would represent the set of algebra tiles you see at the top of the screen here. Now you can work on these questions from your handout. So I'll give you a second, think about what this one's going to be. Hopefully you figured it out by now. You see that there are 2 negative unit tiles and there are 3 negative x tiles. So if we write this in standard form, we always put our variables first, constant goes last, highest exponent goes first. So highest exponent in descending order, constants, that is single, just numbers by itself, always at the end. So then I would get 3x, or negative 3x, minus 2. That's what A is. What about B? B, you should notice that we have 4 negative unit tiles, 2 positive x tiles, 1 negative x square tile. We're going to put the x square first, always. It's a negative x squared, so we write it in. Negative x squared plus, for the positive, 2x minus 4. That's B. Let's do C. In C, you can see we have 1, 2, 3, 4, 5, 6, 7, 8 positive x 1 unit tiles, and we have 1, 2, 3, 4, 5 negative x tiles and 1 positive x square tile. You can see there. So let's write again. We are writing our x squared first, so x squared, and it's positive, minus 5x, because there are 5 negative x tiles, and plus 8, because there are 8 positive unit tiles. And that's A, B, and C. So next example says use algebra tiles to represent the following expressions. Draw your representation. So I'm just going to walk you through this example so you be able to do the rest of the handout and discuss the final conclusion hopefully you should reach as a result of this handout. So A, 2x plus 1. So to do 2x plus 1, I'm going to need 2 positive x tiles, which you can see there. It says 2x plus 1, so now I'm going to need 1 positive unit tile. And there you go, I have represented 2x plus 1. 2 positive x tiles, 1 positive unit tile. Now B, 2x squared minus x plus 3. So let's start with the x squareds. I'm going to need 2 positive x squared tiles. So now I have my 2 positive x squared tiles. I'm also going to need a negative x tile. So that means one of a white rectangle. Got that so far. Now I need 3 positive unit tiles. So you can see I now have 2x squared minus x plus 3. 2x squared minus x plus 3. Doesn't matter which order I put the tiles in. It does matter which order I write my polynomial in. I want to always write that in standard form. So you should know what standard form is from the polynomial definitions page. Alright, let's move on to C. It's got negative 3x minus 4. So I'm going to need 3 negative x tiles, and I'm going to need 4 negative unit tiles. And voila, I have negative 3x minus 4. Negative 3x minus 4. Okay, so now I would want to draw your attention to something that has been implied throughout the first couple activities that you've done, and that is that we can only combine like terms. And what that means in terms of the algebra tiles is that we can only put together, combine, shapes that are the same. So we can combine these 3 unit squares with these 2 unit squares. These 3 unit squares plus these 2 unit squares, so you could think of it as 3 plus 2 is going to equal 5. Right? And I can see that very clearly. I have 5 unit tiles here. 3 plus 2 equals 5. Alright, well what about when they're x tiles? Same thing. Here I have 3x tiles, so that gives me 3x. And here I have 1x tile, so that's just x. So 3x plus x is going to equal how many x's? That's right, it's going to equal 4x. 3x plus x equals 4x. Well, what about if I have negative values then? So, for example, I have negative x squared here, and I have negative 2x squared. Okay, because I have 2x squareds, and they're negative, so I have negative 2x squared. If I add those together, well, count them. What do I have? I have negative x squared, that's 1, 2, 3. I have negative 3x squared. Negative 3x squared. So the key here is that I can only combine the shapes that are alike. For example, let's say I added to this equation that I have here. So this one I have here negative 3x squared. If I were to add, it won't let me move that, so I'll have to add another one. So you can see now I've added a positive x. So this is no longer just negative 3x squared. This is now going to be, this expression is now going to be, and I'll erase this bottom part so that we can see this. If I'm putting together now these 4 shapes, I now have negative 3x squared plus x. I cannot combine the x and the x squared. Okay, and so this is going to be a very important point for us, and I'm going to summarize it in the next slide. So to summarize, like terms are terms that have the same variable and exponent. And what that meant for the algebra tiles are like terms are the same shapes. So let's just see what that means. So for example, if I have 2x and 3x, are these like terms? Well, they have the same variable. They have the same exponent. In this case, no exponent there, though we could imagine a 1's there. Therefore, they are like terms, and they can be combined. They would give us 5x. If we think about this in terms of the algebra tiles, this would be 2 positive rectangles, and this would be 3 positive rectangles, and we can put these together to get 5 positive rectangles, which would represent 5x. 5x tiles, which would represent 5x. So we can combine these two because they are like terms. So what if we have 2x squared and we have 4x? Are these like terms? Well, they have the same variable, x and x, but they don't have the same exponent. This has an exponent of 1, no exponent there that you can see, but we can imagine an exponent of 1. This has an exponent of 2. Therefore, these are not like terms. If I want to put them together, I then have to write them out like this, 2x squared plus 4x. And if we think about it in terms of the algae tiles, then this would be 2 of the black boxes, and this would be 4 of the rectangles. Right? And if I were to describe what I had here just in terms of shapes, I would say I had 4 black rectangles and 2 squares. I couldn't say I had 6. Right? I can't put these together. So I have 2x squared plus 4x because I cannot combine these terms which are not alike. What about this example? 4 and 3, are they like terms? Well, these are like terms that you should be familiar with adding since you were a child, since you were in grade 1 or 2. 4 and 3, of course, are like terms. They have the same variable, no variable. They have the same exponent, no exponent visible. So can we put together these like terms, 4 and 3? Of course we can. 4 plus 3 is going to give us 7. Alright, so now we're going to look at one last example, and then you'll be able to finish the handout by yourself. So, last thing, we're going to be using this word simplify that you see here on the screen quite a bit. And it might seem a little confusing, but the reality is you've been simplifying for as long as you could add and subtract. If I simplify 2 plus 3, it simply means to combine the terms that are alike and get rid of the unnecessary operator. The other way I could express 2 plus 3 is simply as 5. So I simplified 2 plus 3. I got rid of an operator and I expressed multiple terms in fewer terms. So instead of having 2 terms, I have 1 term. So instead of having 2 terms, 2 and 3, I have 1 term, 5. Alright, what about this? 2x plus 3x. Can I simplify this? Can 2x and 3x be combined? Are they like terms? Do they have the same variable and the same exponent? The answer is yes. Same variable, same exponent. They can be combined. 2x plus 3x is going to give me 5x. I've simplified. I've gotten rid of an operator. I've gotten rid of the operator, the plus sign, and I've written 2 terms as 1 term because I can combine those 2 like terms. How about 4x squared minus x squared? Can these be combined? Are they like terms? They have the same variable and the same exponent. X squared. 4x squared minus x squared. And just think of it in terms of our algebra tiles for a moment. If I had 4 black squares and then I had 1 negative x squared, well, remember that I would have a 0 appear there. 2 of them would cancel each other out. So I would end up with 3x squared. And just to show you what I'm talking about with for that question really quickly, hopefully I can do it quickly, I have 4 of these, and they're colored in because they're positive, and then I have 1 negative one. Well, these two cancel each other out because it's positive 1 minus 1. That gives us nothing. Cancel each other out. It's a 0 pair. So how many do I have left? I have 3x squared left. So how about negative x plus 2x? Negative x plus 2x, I'm going to draw that out so we can see it. First, let's think, can we combine it? We can combine it. They're like terms. They have the same variable, and they have the same exponent, 1, or none visible. So we can definitely combine them. So let's draw out the algebra tiles so you can maybe see what these would be. So they are going to be rectangles, and we have 1 negative 1 that's just white, and then we have 2 positive ones, so they're darker. And remember what happens when we have a pair like that of 1 negative and 1 positive, 1 negative, 1 positive, is that they cancel each other out. So these, we can get rid of these, and what are we left with? We're left with positive x. So our answer then for this is just x. Alright, so what about x squared plus 2x? Can we combine those? Well, we have to ask ourselves, are they like terms? Does it have the same variable? It has the same variable. Does it have the same exponent? Oh, it does not have the same exponent. Therefore, I cannot combine these. This is already simplified. If asked to simplify it, this is already the simplified. This is as simplified as it can get. We can't reduce it any longer because those terms can't be combined. How about the next one? X plus 1. Can x and x be combined? Yes, they are like terms. They have the same exponent, the same variable. So we can combine them. X plus x is going to give me 2x plus 1. Plus 1 is going to have to stay there. We can't get rid of it because we can't combine it with the x. We get 2x plus 1. Keep our theme. 2x plus 1. Okay, we took 3 terms, we wrote it as 2 terms. We were able to simplify that, but we're not able to simplify it beyond this because we can't add the 1 to the 2x. 2x squared plus x plus 1. Well, are there any like terms here that we can combine? We have 2x's, but they have different exponents. They can't be combined. This has no exponent or variable, therefore none of these can be combined. This is already the simplified expression, 2x squared plus x plus 1. So I've taken you a little bit beyond what the handout has started you with, but this is a good introduction to using algebra tiles and thinking about algebra tiles. Key points for us to remember: only like terms can be combined, only like terms that have the same, and like terms have the same variable and have the same exponent. And a way to think about that in terms of algebra tiles, we can only put together tiles that have the same shape.